Hello students, welcome to the amazing platform of Physics Wallah. Today we are going to discuss about concentration terms in a booster pack. I hope all of you are excited because concentration term is a very important topic which we discuss in the early starting of 11th, that is your mole concept chapter, and also you use the same topics again in 12th in the solutions chapter. So it has double importance, right? Yes. So today we are going to excel this particular topic. So let's get started. So my dear student, first of all, if we talk about the concentration terms, before that we need to know what is the solution. Why do we need to study about solution? Because you are going to talk about the concentration terms of a solution, right? Yes. So you need to know what is a solution. So, my dear students, a solution is a homogeneous mixture. It is a homogeneous mixture. First, let's read the definition. A solution is a homogeneous mixture beyond the dimensions of atoms and molecules of two or more than two components. This means that a solution can have two components. It can also have more than two components. Yes. Now, let's talk about the component system. Just a second, let me set the wire, right? Yes, okay. So now, my dear students, how are we going to talk about the components? Let's take the example of day-to-day life. You take water, yes. If you want to make a lemonade, what do? You take water, you add sugar to it, right? Yes. So how many? It is a solution now? Yes, ma'am. And it is a homogeneous solution once the sugar is mixed. Can you differentiate both of them? No, ma'am. That is a homogeneous mixture. And it has two components. It has water and it has sugar. But you also need to add the salt, right? Can you add the salt there? Yes, you can add the salt as well. So now you have total three components in one solution. This means that a solution is not necessary. It should have only two components. It can have more than two components as well, right? Yes, we know that there will be solute and solvent. We'll discuss about that as well. So let's get started again. Okay, so now when we talk about components, how do we classify them? We classify them as solute and solvent, right? Yes. So the question is, how many solutes you can have? How many solvents you can have? You can have n number of solutes and n number of solvents? No. Always and always remember that you can have only one solvent. Solvent can only be one. Now, you can have more than one solutes. This means that you can have one solute, two solute, three solutes. When we talk about the lemonade, actually the water was your solvent, okay? And you added sugar, that was your solute. And you added salt, that was your another solute. This means that in a solution, you can have only and only one solvent, but more than one solutes, right? Yes. So this is what it is written here. A solution has only one solvent, but one or more than one solutes, right? Yes. Let's move forward. Now, in questions, when you will talk about the concentration terms, you'll always come across the word aqueous solution. What does aqueous solution means? Mark it to your mind, my dear students, that aqueous solution means that your solvent in this particular solution would be water. So whenever a solution is aqueous, this means that solvent is water. It is told to you that your solvent is water, right? Yes. Solute is the reactive part. Always, my dear students, solute is actually the reactive part. Solvent never takes part in the reaction. It actually provides the medium. It only and only provides the medium. It never takes part in the reaction. Okay. So solute is the reactive part and the solvent provides the medium of the reaction. Okay. The amount of solute in a solution is represented by concentration of the solutions. Now the question comes, ma'am, you told us about solute, you told us about solvent, you told us about aqueous solution. But how are we going to measure that how much of solute is dissolved in how much of solvent, right? Yes. All these things are discussed in this particular part, which is your concentration of solution. How much of your solute is actually present in a particular solvent is referred to as the concentration terms, right? Yes. Now concentration terms can be of different type. Now we are going to discuss about that. Okay, let's move forward. So now here I have water, and I'll take myself here as another object. Okay, so now what you have to understand is, first let's understand by me and then you'll understand this as well. Okay, so if I talk about my height, then some people will give me my height in terms of centimeters, some people will tell my height in terms of feet, right? Yes. So if this is me, I'm making myself. Okay, see, okay, I can have a very bad drawing, but yeah, just for fun. Okay, see. Okay, I have my hands, right? Yeah. I am dancing actually, see. Okay, yeah. So now, my dear students, if I talk about the height, then height can be in terms of feet, it can be in terms of centimeters and many other units, right? Yes. But will the height change? No, ma'am, the height will not change, right? Yes, you're just giving the same height in different units. The same is true for for the concentration of a solution. You have a solution, you have a solute added to a solvent, right? Yes. Now, concentration terms is actually that how much of solute is dissolved in how much of solvent. Now, if you talk about how much grams of solute is dissolved in how much milliliter of solution, that would be another concentration term. How much moles of solute are dissolved in how many moles of solvent, that would be another concentration term. But will the solution change? No, the solution is not changing. What are you doing? You're just expressing them in different units, the same way you expressed the height in different units, right? Yes, that is what is known as concentration terms, and that is the reason that you can interconvert the different types of concentration terms of the same solution. You can calculate molarity of a particular solution, you can calculate the molality of the same solution, you can calculate the mass percentage of that particular solution. This means that all the concentration terms can be calculated for the same solution because you are just expressing them in different units, right? Yes. So now I hope you got the idea. The concentration of the same solution can be represented by different units of concentration, right? Yes. And by the way, this is me. Okay. Now let's move forward. Now we are going to talk about the molarity. What is molarity? The first concentration term and the most important concentration term which you will come across all the time in chemistry, which is molarity. What does molarity tell you? Molarity actually tells you that how many moles of your solute are actually dissolved in 1 liter of your solution, right? Yes. So this means that you will have 1 liter of solution, and how many moles have you added in that will give you molarity, right? Yes. So it is the number of moles of solute present per liter of the solution. Now, if the solute is added in solid state, the volume change of mixing will be neglected. Perfect. Now let's write the formula of molarity. Molarity is always denoted by capital M. So first and the most important thing which you need to understand is it is represented by capital M. The formula would be moles of solute divided by volume of solution in liters, right? Yes. So this is the formula for molarity. Okay. Now I am going to give you an example that what if you are given some molarity of a solution. Let's say you have 3 molar aqueous NaOH solution. Okay, so now how are you going to interpret from this everything? Okay, so now if I talk about 3 molar solution, this means that I have 3 moles. I have 3 moles of solute, and 3 moles of solute are present in 1 liter of solution. So what does this tell me? This tells me that I have 3 moles of solute is NaOH. Yes, present in 3 moles of solute are present in 1 liter solution. Okay. What is my solvent, my dear students? Here aqueous word is written, so I can say that here one more information I know, that my solvent is water. And what is your solute here? Solute is your NaOH. Okay, so from this particular one line you have found out so many informations, right? Yes, so this is how you are going to find out everything, and then the question solving would be just a in just a second you can solve the questions as well. Okay, so now let's move forward. Let's try a question. Okay, the question says that 4 grams of NaOH in 250 milliliters of water. You have this as your solute. I hope you get this. Yes, ma'am, NaOH is my solute and water is my solvent. I have 4 grams of NaOH dissolved in 250 ml of H2O, neglecting the volume change. Since it is telling me that I have to neglect the volume change, I can say that volume of solvent is actually equal to volume of solution. Right? Yes, because there is no change in volume. This will be equal to 250 ml. Okay, calculate the molarity of the solution. Right? Yes. So, molarity is moles of solute upon volume of solution in liters. Perfect. So, what is moles of NaOH, my dear students? What is the mass given? 4 grams. What is the molar mass of NaOH? It is 40 grams per mole. So 40, this would be 1 upon 10, right? So basically, the moles are 1 upon 10 divided by volume of solution in liters. Volume of solution is 250 milliliters. I have to convert it into liters. So 250 divided by 1000. This would be 4 upon 10, which is equal to 0.4 molar. So basically 0.4 molar is the molarity of the solution. This is how you have to solve the questions, and they are very easy, don't worry, right? Yes, once you're clear with the concept, question solving is just a play. Right? Yes, let's move forward. Now we are going to talk about something very important, which is millimoles. What is the concept of millimoles? When you'll see the questions on the concentration terms, you'll mostly see the volume is always and always given to you in milliliters. Okay, so once you'll convert that volume into liters and then you'll calculate moles, that would be a very hectic task. Okay, so we study the concept of millimoles. I'll just tell you how. We know that molarity is equal to moles of solute upon volume of solution in liters. Right? Yes. So from here, if you have to calculate the moles of solute, you will say it is equal to molarity into volume of solution in liters. What if my volume is taken in milliliters? What will happen? If my volume, this molarity is molarity, okay? But if you take the volume of the solution in milliliters, then the calculated thing would be your millimoles. So what is millimoles? It is nothing. It is just a fancy term given to moles when you calculate them by using volume of the solution in milliliters. You do your all the calculations in millimoles, and at the end just convert it into moles by multiplying into 10 raised to the power minus 3. So moles is equal to millimoles into 10 raised to the power minus 3. So at the end of the question, you can just convert them into moles. Your calculation would be easy. It's your choice. If you want to do it like this, you can do, and if you want to just convert this milliliter volume into liter volume and then calculate moles, that is also your choice. Okay, I just wanted to give you a concept which you can use and make your calculations easy. Okay, perfect. Now let's move forward, my dear students. Next is mixing of two solutions. Now let us say you have two different solutions. Both of the solutions will have different molarities. Now you're going to mix both of them. If you mix both of them, that is known as mixing of solutions, and the new solution will have, definitely it will have a different molarity. Yes, so you have to calculate that molarity. Let's talk about this. See, if you talk about the first solution, I have a solution, right? Yeah, and it is 0.1 molar, and I have 400 ml of volume here. I mix this with the another solution, which is 8 whose molarity is 0.4 molar again, and volume is 800 milliliters. I mixed both of them and I got a new solution. I have to calculate the molarity of this new solution. How are we going to do that? Right? My dear students, always and always remember that you can never add the molarities. If you calculate, let us say you calculate molarity 1 here, you calculate molarity 2 here, and you will say, ma'am, molarity 3 is actually equal to molarity 1 plus molarity 2. This is wrong. This is not possible. This is not right. You cannot add molarities directly. Okay, but you can add number of moles directly. So what I want to tell you here is, can I calculate number of moles here? Yes, ma'am. You can calculate number of moles here, right? Number of moles would be molarity into volume. Molarity is 0.1 and volume is 400. But my dear students, it is in milliliters. So actually we are calculating millimoles. Okay. So ma'am is actually calculating millimoles. Into volume is 400. So this would be 40. Let's calculate here. Millimoles would be 0.4 into 800, 0.1, 0.4, yes. So it is, first of all, it would be 4 into 80, 844, 32, just a second. This would be 32 and the 320. Okay, yes. So here millimoles are calculated as 40, here 320. So I know that this particular solution has number of moles equal to 40. It has number of moles equal to 320. Same solution, same solute. So the total moles here would be, millimoles would be, adding these two. Yes, I'll add these two. This will be 320 plus 40, which would be equal to 360, right? Yes, and volume total would be, if you're mixing these two, the total volume would be the addition of the volume, which is 800 plus 400, which is equal to 1200, right? Yes. So the molarity of this solution would be 360 millimoles upon 1200. My dear students, volume is in milliliters, right? So this would be milliliters. I can cut milli to milli, yes. So it is moles per liter, which is actually your molarity. So now you can calculate it directly. 36 upon 120, right? Yes. So this is how you are going to solve these questions, right? Yes. So I hope you got the point, right? This is how you're going to calculate the molarity of the different solutions. And if they are mixed, you calculate the moles of each solute, you add them and you get your answer, right? Yes. This is how we do the mixing of the two solutions. Now let's move forward. Next concept is dilution of solution. What does dilution of solution mean? Dilution of solution actually means that you have a solute, you have a solvent, you have a solution. Okay. So I have a solute. In this, I have a solute, I have a solvent. What do? I add some more solvent to it. Nothing is happening to the solute. I have just added more of the solvent to it. So I have done the dilution. If I add more and more water, we do the dilution. So more the solvent you're adding, it is more of the diluted solution. But you're not doing anything to the solute. Okay. So what will happen, my dear students? This is how you have a solute where you had number of moles equal to N1 of the solute, and let's say volume of the solvent is V. Okay. Let's say you added some X volume to the solution. You got a new solution. Yes, now you will have a new solution. Its molarity is M1. What will happen here? Ma'am, the number of moles of solute are intact. You've not done anything to the solute, right? Yes. So solute would be still N1. What will be the solvent? Volume. You have increased the volume. So V dash would be equal to the initial volume V and the volume which you have added, which is X. So here the second molarity would be number of moles divided by volume, which is V plus X. Here, my dear students, molarity M1 would be number of moles divided by V. I know that N1 and N1 are equal. So from here I can say N1 is actually equal to M2 into V plus X. And here N1 is equal to M1 into V, right? Yes. So this is your first equation. This is your second equation. These both should be equal. These both should be equal. So for dilution, what do we say? That m1 into v will be equal to m2 into v plus x. So you have to just remember that since the moles are equal, so you only have to equate both of their relations. Okay, and you can calculate everything. So if you know the concept, if you're not memorizing it, if you're understanding the concept, you'll understand each and everything, my dear students. You'll be able to solve every question. Okay, so now let's solve a question and understand this more clearly. What volume of water, it is asking that what volume of water should be added to 250 ml and 2 molar NaOH solution. So this means that you have a solution where the molarity is 2 molar and volume is 250 ml and you have added some V volume. Okay, yes. So that the molarity is reduced to 0.5. So here, when a new solution is made, you can understand that the new molarity is 0.5. Right? Yes. Let's say the volume is V dash, that would be 250 plus V, right? Yes. And I know that number of moles of solute are equal. So here the number of moles of solute is 2 into 250. Here the number of moles are 0.5 into 250 plus V. I know that number of moles of solute are equal. So these both should be equal. So 2 into 250 should be equal to 0.5 into 250 plus V. Okay. So you just have to solve this and you will get the volume V. So this is how you are going to solve the questions. Very easy. And this volume V, which is 2 into 250. No. We have to first solve it. So this would be 2 into 250, 0.5 into 250. Plus 0.5 into V. So now you can solve it and you will calculate the volume V. Do let me know in the comment section what volume it came out to be. Also with the unit, will it be milliliters or will it be liters? That is your homework. Okay, so you have to tell me the volume in not only the numerical value, you have to tell me the units as well. You'll use milliliter or liter. Let's see which of the that you understood or not. Which unit you will tell me. Okay, that is the main important part. Okay, let's move forward. You can calculate it. Now let's move forward. And the other concentration term is molality. What does molality stand for? Molality stands for the moles of solute per kg of solution. So it is the number of moles of solute present per kg of the solvent. Molality is moles of solute present per kg of the solvent. Very important thing to understand, my dear students. It is denoted by small m and the formula would be moles of solute divided by mass of, not solution, this time it is solvent, and that too in kg. Okay, yes. So if I tell you you have 3 molar aqueous NaOH solution, so what does this mean? This means that you have 3 moles NaOH present in 1 kg, this time solvent, and you are given aqueous. Aqueous means solvent. Solvent means water. Aqueous means water as your solvent. So 1 kg of water, my dear students. Why? Because here it is solvent, not solute. That is something which you have to pay attention to, right? Yes. Let's move forward. I hope you got this point. Now let's solve a question and be clear with the concept, right? Yes. So 4 grams of NaOH is added to 100 milliliters of water. You have moles of solute. Your solute is NaOH. Mass is 4. Molar mass is 40. So 1/10 moles of solute added to 100 ml of water, and you are given the density of water, because I know that water is solvent, and for molality I want the mass of solvent. You are given volume, so density is equal to mass upon volume, right? So mass is equal to density into volume. Density is given as 1, volume is 100. So basically 100 grams is your mass of solvent, right? Yes. So molality would be moles of solute 1/10 upon mass of solvent in kg. It is in grams, so 100 upon 1000. right? So basically 1 molal is your correct answer. So the molality of the solution is 1 molal, right? Yes. So this is how you're going to solve the question. Very good. Let's move forward, my dear students. The another concentration term is mass by volume. So how do you study the concentration term mass by volume? Mass by volume percentage means that it gives you the grams of mass present in 100 ml of solution. Okay. You didn't get this, right? Yes, ma'am, please explain us with a particular example. So, if you are given that you have 20% mass by volume aqueous NaOH solution, this means that you have 20 grams of your solute NaOH present in 100 grams of your solution. So, this is how you're going to read. Always and always remember, now it is mass by volume. I'm sorry, students, it is mass by volume, not mass by mass. So this would be 100 ml of solution. Okay. Always remember that first mass, this means that it is talking about the solute, and the other part, which is volume, now this volume will be talking about the solution, and the unit would be milliliters if it is volume, and if it is mass, it will be grams. Okay. Perfect, no issues. I hope you got this point. Now let's move forward and solve a question. The question says that you have 0.4 moles of NaOH dissolved in 500 ml of H2O. Neglecting the volume change, calculate the mass by volume percentage. I know that here mass by volume percentage formula would be mass of solute divided by volume of solution in milliliters into 100. This would be the formula, right? Yes. So now we are going to use this formula. Perfect. See, you are given 0.4 moles of NaOH. So mass of NaOH will be equal to number of moles into molar mass. Number of moles 0.4, molar mass is 40. So 4 into 4, which is 16 grams. So my dear students, 16 grams is your mass of the solute. So now you have to calculate mass by volume percentage. Mass of solute is 16, volume of solution is 500, and you want volume in milliliters only, into 100, right? Yes, this would be, here it would be 16 upon 5%. 16 upon 5%, right? Yes. So this is how you are going to calculate the mass by volume percentage, right? Yes, I hope you got this point. Perfect. Very good, my dear students. Let's move forward to the next question. Okay, the next concentration term is mass by mass. I hope now you can write this on your own. So try to write on your own, pause the video, and then give me the answer in the comment section that you were right or wrong. Okay, so if we talk about mass by mass, this means that mass, if I take an example, 20% mass by mass aqueous NaOH solution. So this means that you have 20 grams of NaOH, which is your solute, present in 100 grams of solution. This time the mass grams would be for solution, right? Yes, this mass is for solution and this mass is for your solute. So if you have to write the formula, what will it be? Mass by mass percentage will be mass of solute, it will be in grams, divided by mass of solution, this will be in grams, into 100. This will be your formula for the mass by mass percentage. Always remember, mass of solution is equal to the mass of solute plus mass of solvent. So if you are given the mass of solvent, you actually have to first calculate the mass of solution and then use it in the formula. Don't make a mistake of using the mass of solvent as your mass of solution. Okay, don't make this mistake. That is the most common mistake that students do. Okay, perfect. Now let's move forward, my dear students. Next is volume by volume. I hope now you can write volume by volume also on your own. Let's write it. For volume by volume, I know that if I have 20% volume by volume aqueous NaOH solution, what will it mean? It means that you have 20 milliliters. This time volume will be, this volume is for solute, that volume is for solution. 20 milliliters of NaOH present in 100 milliliters of solution, right? Yes, this is how you're going to write it. If you have to write the formula, then volume by volume percentage will be volume of solute. This will be in milliliters divided by volume of solution. This will be in milliliters into 100, right? Yes, again you have to keep in notice that volume of solution is equal to volume of solute plus volume of solvent. Don't make a mistake of using solvent as your solution, right? Yes, these are the things which you have to keep in mind. Now let's try the questions and excel this part. Now the question is on your screens. You have to solve the question. The question says that a bottle of commercial sulfuric acid, you have a bottle of commercial sulfuric acid, okay, and the density is given as 1.787 grams per milliliter, is labeled as 86% by weight. So 86% by weight means that you have 86 grams of sulfuric acid, that means H2SO4, present in 100 grams of solution, right? Yes. What is the molarity of the acid? You have to give the molarity. For molarity, I know that I want moles of sulfuric acid. Sulfuric acid is my solvent, and volume of solution, sulfuric acid is my solute, right? And volume of solution in liters. See, I have mass of H2SO4, so I can calculate moles of H2SO4. 86 upon, if you calculate this, what will it be? It would be 4 oxygen, 16 into 4, 64, plus 32, plus 2, 4, 4, 8, 9, 98, right? Moles are calculated. You need volume of solution, but you have mass of solution, right? How can you calculate the volume of solution? You are given density. I know that density is equal to mass by volume, so volume is mass by density. Mass is 100, density is 1.787. So this is your volume in milliliters. So moles are 86 upon 98. Volume is 100 upon 1.787. But the most important thing is it is in milliliters. You have to convert it into liters by dividing by 1000. So you will divide it by 1000 as well. So this is how, if you will calculate this part, my dear students, you will get the molarity of the solution. So you need to take care of the units as well. The most important thing which most of the students make mistake with, the units of the solution, right? Yes, you change the units, you solve this, you will get the molarity of the solution, right? Yes, so I hope you got this point. Very good, my dear students. Let's move forward. So you have density of a solution, 13% mass. So can I give you this as your homework? I have done one question. The other question will be your homework, right? Yes. So this is your homework question. You have to solve this question on your own, and you have to give me your answer in the comment section. Okay, I'll definitely check. I always check your answers. Okay, very good, my dear students. Let's move forward to the next question. Now we are going to talk about the conversion of concentration units. Okay, conversion of one concentration unit into the other. Okay, so calculate the molality of 10% mass by mass of NaOH solution. So now we are doing this. Okay, so you have 10% mass by mass NaOH solution. This means that you have 10 grams of NaOH in 100 grams of solution. Right? Yes. And you have to calculate the molality. For molality, I need moles of solute upon mass of solvent in kgs. NaOH is my solute, so I know that 10 upon 40 will give me moles of solute. Mass of solvent, I have mass of solution. I know that mass of solution is equal to mass of solute plus mass of solvent. So if I have to calculate mass of solvent, that will be mass of solution minus mass of solute, right? Yes. So solution mass is 100, solute mass is 10. So the mass of solvent will be 90 grams, right? So use this 90 grams here. It is in grams, so you have to divide it by 1000. You will get in kgs. You have to solve this and you will get your answer, right? Yes. So you will have to solve this, right? Yes, ma'am is not going to solve all the questions. This is your part to do, right? Yes. See, I've done most of the calculation, right? Yes. So this is how you're going to calculate the molality. This is how you're going to convert one concentration term into the other concentration term. But you're actually talking about the same solution, right? Just the units are changing, right? Perfect. Very good. Let's move forward. So now we are going to talk about the mole fraction. Now we are going to talk about the mole fraction. There are a lot of practice questions for you in this particular part. So solve the questions and try yourself, my dear students. I'll give you the idea of each and every concept. So next concentration unit is mole fraction. Mole fraction is denoted by chi. What does mole fraction tells you? Since the word tells you fraction, it means it is telling you something about fraction. I told you a solution can have more than 2 components. It can have 2, 3, 4, 5, 6 components, right? Every component has its individual mole fraction. How do you calculate mole fraction? For a particular component, you will calculate the mole fraction as moles of that particular component divided by the total moles, right? Yes. So it is the fraction of the total number of moles. Sum of the mole fraction of all the components is always 1. Imagine you have A plus B plus C. You have a solution of 3 components. Let us say its moles are moles Na, Nb and Nc. So if you calculate the mole fraction of A, it will be moles of A upon total moles, which is Na plus Nb plus Nc. Mole fraction of B will be moles of B upon total moles, moles of A plus moles of B plus moles of C. Similarly, mole fraction of C will be moles of C upon moles of A plus moles of B plus moles of C. So now if I talk about the sum of all the mole fractions, that is mole fraction A plus mole fraction B plus mole fraction C. This will be equal to moles of A plus moles of B plus moles of C upon total moles. And my dear students, if you see, the answer is coming out to be 1. So if a solution has 2 components, the sum of the mole fractions of both of them would be 1. If a solution has 3 components, mole fraction of all of them will be 1. So how many components? Sum of all the mole fractions would be equal to 1. Right? Yes. So this is how you talk about the mole fraction. Let's solve some question and understand the concept. Calculate the mole fraction of water in a mixture containing, you have 0.4 grams of moles of NaOH. Let's calculate. It is 0.4 upon 40, which is 0.01. This is the moles of NaOH. The other component is water. Moles of water would be, given mass is 1.8, molar mass is 18, so 0.1, right? Yes. So you have to calculate the mole fraction of water. Mole fraction of water would be moles of water upon total moles, which is 0.1 upon 0.11, right? Yes, this would be 10 upon 11. So this is the mole fraction of water. Now, if I ask you what is the mole fraction of NaOH, it is not going to be difficult. You know that it has 2 components. So mole fraction of NaOH plus mole fraction of water should be equal to 1. So the mole fraction of NaOH will be equal to 1 minus mole fraction of water. Right? So this means that 1 minus 10 upon 11, which is equal to 1 upon 11. See, such a easy task, right? Yes, if you've calculated one, you can calculate the other as well. Easy? Very good. Let's move forward to the next question. Calculate the mole fraction of NaOH in 40% mass by mass aqueous solution. So are you going to do this question? I'll give you a hint, okay? Again, this is your homework question. I'll give you a hint. You have to calculate the mole fraction NaOH in 40% mass by mass aqueous solution. So my dear students, 40% mass by mass aqueous solution, right? So this means that you will have 40 grams of NaOH present in 100 grams of solution. You have a solution of two components, water and NaOH? Yes. Aqueous solution tells you the solvent is water? Yes. Mass of NaOH would be 40 grams. What will be the mass of water? 100 minus 40. That is the biggest mistake which you will do. But don't do that mistake. Okay. So the mass of water would be 100 minus 40, which is 60 grams. Now you have mass of solute and mass of solvent. Calculate their moles. If you will calculate their moles, you can calculate their mole fraction as well, right? Yes. So this is how you're going to solve this question. I have given you all the steps. You only have to follow them. Okay. So do this question and let me know your answer in the comment section again. Okay. I'll definitely check your answers. Very good. Perfect. Calculate the molality of an aqueous solution in which the mole fraction of solute is 0.25. A very good question. Now we are going to solve this question. Okay. So what does it say? You have to calculate the molality of an aqueous solution. It is a very important question, my dear students, which is a lot of times asked in the exam as well, right? In your NEET exam, in your JEE exam, it is asked. So now let's solve this question. Calculate the molality of an aqueous solution in which the mole fraction of solute is 0.25. You have a binary solution. You have only two components. If the mole fraction of the first component is 0.25, I know that mole fraction of the other component will be 1 minus 0.25, which is 0.75. Okay, you have to calculate the molality. I know that molality is moles of, let's say moles of AA is your solute upon moles of solvent, right? Sorry, it is mass of solvent, na? So it is mass of solvent in kg. Okay, this is how you have to calculate the molality. See, if you talk about the mole fraction, you can say this is equal to moles of A upon total moles, and you can say this is moles of B upon total moles. If I divide both of them, what will I get? Mole fraction of A upon mole fraction of B is equal to moles of A upon total moles upon moles of B upon total moles. Total moles can be cancelled, so you will get moles of A upon moles of B. So the ratio of the mole fractions actually gives you the ratio of their moles. Okay. I know that the solvent is aqueous, solution is aqueous. This means solvent is water. So my B is water. If I want to calculate the mass of B, I can multiply it by the molar mass, which is 18. If I am multiplying by 18 here, I'll have to multiply 18 here as well, just to make it equal, even. If you talk about this particular part, what is this? This is actually the mass of solvent, your B part. Yes, number of moles into molar mass gives you mass. Yes. So this is how you have calculated it, but this is in grams. You have to convert it into kgs. So you have to divide it by 1000. So divide it by 1000. Right? Yes. If you are multiplying by 1000 here, you will have to multiply by 1000 here as well. Now, my dear students, if you very, very keenly observe here, this is actually what? Molality. So this is also molality. So how are you going to calculate the molality? Mole fraction of A 0.25, mole fraction of B 0.75 into 18 into 1000. This is how you're going to calculate the molality. 1,3,000 upon 18 into 3 molal. This will give you the molality of the solution, right? This was very important, very, very important part, my dear students. What you have to do, only you have to calculate the ratios. If you calculate the ratios, then multiply it by the solvent's molar mass. I have multiplied it by the solvent's molar mass. Since this mass will be in grams, I'll have to convert it into kgs. So I converted it into kg divided by 1000, and this is how I have calculated the molarity, right? Yes. So this is how you will calculate the molality. Easy? Yes. Try this yourself. Only then you will be able to understand it. Okay. Yes. Very good, my dear students. Let's move forward to the next part. So here is a practice question. We have talked about dilution as well. See, 1 molar HCl and 2 molar HCl. You have two different solutions. You are given molarities are mixed in volume ratio of 4:1. So I'll do this question for you. You only have to calculate the answer. See, you have two solutions. One is 1 molar and the other is 2 molar. Okay, and their volumes are in the ratio 4:1. So let us say its volume is 4x, then its volume would be x. You mixed both of them. What will you get? A new solution. You have to calculate the total moles here and you have to calculate the total volume here. So if you talk about the moles here, this would be molarity into volume. So 1 into 4x. Here moles would be 2 into x. The total moles would be sum of both of them, which is 4x plus 2x, which is equal to 6x. So this is your number of moles. If you talk about the total volume here, it would be the sum of both these volumes, which is 4 plus 1, 5x. So this would be 5x. So what will be the molarity? The new molarity would be number of moles of solute, which is 6x upon volume of the solution in liters, which is 5x. So you cut x by x. So basically what will you get? You will get 1.2 molar. Do you have this option? Yes. So option C will be your correct answer. So this is how you are going to solve these questions, right? Yes. Perfect. Let's move forward. Okay, students, with this, we have came to the end of our session. So I hope you got each and every part. The questions which I have given you as your homework, try to see the hints first and then try to solve the questions. Do give me your answers in the comment section and do let me know how did you find today's session. I found it very interesting because this is a very important topic for your exam. Till then, keep studying. All the very best.